our next lesson, lesson 6, has us using subtraction quite a bit in this lesson to talk about the distance between two rational numbers, or the difference between two rational numbers, and again, difference meaning subtraction. So for exercise 1, go ahead and complete it and then continue the video. And you may find it easier to see the distance between two numbers if you use a highlighter on the number line and highlight the distance between the two numbers. So go ahead and do that and then continue the video. All right, you should have ended up with answers such as these. Again, the highlighting is not done on the examples here, but it might help you figure out the answers to these. So the distance between -4 and 5, -4 and +5 is 9, and the distance between 5 and -4 is also 9, and so on and so forth. All right, so a common mistake is that students count the first number as 1 instead of it being 0. Another common mistake is that students describe the distance as negative. Remember, distance can't be negative, so you always want to make sure that you describe distance is always positive. All right, so let's discuss what our observations are. So what is the distance between -4 and 5? Well, that was 9. And the distance between 5 and -4 is also 9. So were the answers the same for the second and third problems as well? And that is yes. So why did we get the same answers for all three problems? Why is -4 and 5 9, and why is 5 and -4 9? Well, because the endpoints are the same, so the distance between the two numbers is also going to be the same. So take a minute to think of a destination that you or your family usually travel to. For example, a relative's house or the location of an activity you attend each week. Assuming you take the same route to and from the location, what is the approximate distance in miles that you travel each way? Well, you should recognize that distance is the same to and from the location and should state that the same number of miles, whether traveling from home to the location or from the location back to home, is always going to be the same. So in life at any given moment, will we always be able to use a number line to find distance between two rational numbers? Is it the most efficient way to calculate distance between 2 points? Well, the answer to that is no. So we have to come up with a way that we could do it numerically. So what represents the distance between a number and 0 on the number line? Well, we've talked about it before, and that would be absolute value. So if the distance between 5 and 0 can be calculated using the absolute value of 5 minus 0, or the absolute value of 5, do you think we might be able to calculate the distance between -4 and 5 using absolute value? Take a minute to see if this works. So find the absolute value of -4 and 5 and see if you get 9. Well, the answer is yes. If you take the absolute value of -4 minus 5, that's the same as -4 plus a -5. That gives you the absolute value of -9, which is 9. And even if you did it the other way, 4 minus a -5, which is the same as 4 plus 5, that gives you the absolute value of 9, which is also 9, and that is also the same answer we found in exercise 1. So will this work for the other two instances we looked at in exercise 1? Go ahead and try it out. When you are done, continue the video. All right, so if you're done with that, you should have come up with yes. It doesn't matter which way you subtract the two numbers. The difference is always going to be, well, they're going to be the opposite, but because we're finding the absolute value, we're going to end up with the same answer. So exercise 2, go ahead and complete this before continuing the video. Consider determining the distance on the number line first, then use the formula to verify rather than the other way around. So go ahead and model it on a number line and then go ahead and use the distance formula to verify it. All right, you should have finished all the problems for exercise 2. So for the first one, part A. For part A, you would have modeled the distance between 0 and -8, which is 8 units. And then using our absolute value of P minus Q, if you did 0 minus a -8, that is the same as 0 plus 8, and the absolute value of 8 is 8. You could have also done it as -8 minus 0, which is the same thing. -8 plus 0 is -8, and the absolute value of -8 is 8. So either way, either order that you do the numbers is going to still get you 8. For part B, same thing. The distance between -2 and -1.5 is 1/2. And if you subtract the two numbers, that's the same as -2 plus +1 and 1/2, which is a -1/2, which again, the absolute value of that is 1/2. Or if you did -1/2, or -1 and 1/2 minus a -2, would give you a +1/2, which is, again, the absolute value of +1/2 is 1/2. And the absolute value of the distance between -6 and -10 is 4 units. -6 minus a -10 is the same as -6 plus 10, which is -4, which is 4. Or if you did -10 minus -6, that would give us a +4, which again is still 4. All right, so let's take a look at example 1. If P and Q are rational numbers on a number line, then the distance between P and Q is the absolute value of P minus Q. It does not matter which endpoint we call P or which endpoint we will call Q, because distance is always positive. So for example 1, the steps are to find -3 first, and then find that, or count the number of units from -3 to +2, which is 5 units. And again, they show both orders. You can do -3 minus 2, or you could do 2 minus a -3. In this instance, we get -5, but again, finding the absolute value gives us a +5. And in this instance, we get 5, and again, the absolute value of 5 is 5. So it doesn't matter the order that we put P and Q. All right, for example 2, change in elevation versus distance. Remember, distance is positive. So the change in elevation or temperature may be positive or negative depending on whether it's increasing or decreasing. So now you have to look at the context of the problem. So let's take a look at number 1. If a hiker starts hiking at the beginning of the trail at a point which is 200 feet below sea level, and he hikes to a location on the trail that is 580 feet above sea level, what is the vertical distance from 200 feet to 580 feet above? Well, so if our starting point is -200 minus 580, then that would be -200 plus a -580, which is -780. But the absolute value is 780, so it's a change of 780 feet. But what does that mean in the context of the problem? Well, that means that he hiked 780 feet from a point below sea level to a point above sea level. So again, we have to answer it in the context of the problem. So this time he's going up. Now after lunch, the hiker hiked back down the trail from a point of elevation which is 580 feet above sea level to the beginning of the trail, which is 200 feet below sea level. So what is the vertical distance between 580 and 200 feet below sea level? So now we have to do 580 minus -200, which is 580 plus 200, which is now positive 780 feet, or 780 feet. So what is the change in elevation? Again, it's 780 feet, but he went down this time. So you have to look at the context of the problem and answer the question that is being asked. All right, for exercise 3, go ahead and complete that. There are infinite possible answers, so when you are ready to continue, you'll be given one example for an answer. Make sure that your answer models this example. So you want to make sure you model it on a number line, and then again use the distance formula to prove that your model matches your answer. All right, if you finished exercise 3, it asked you to find the distance between two numbers. A negative number and a positive number is 12.5. So what two numbers did you pick? In this particular instance, they did negative 9.5 and 3. You could have picked something different. But again, modeling it with the number line and also modeling it with the distance formula to show that the answer is indeed 12.5. And then again, showing the absolute value of negative 9.5 and the absolute value of 3. So consider the different solutions. We'll compare these in class. Notice that in each case, if we take the absolute value of each endpoint, their sum is 12.5. Is that the case for exercises 2, A through C, and why not? Well, it's not always the case. If you have a positive number and a negative number as endpoints, they are separated by 0, because 0 is in between. And since the absolute value of a number's distance from 0, taking the absolute value of each endpoint and adding them together will give you the same results as using the formula P minus Q and taking the absolute value of that. So go ahead and complete exercise 4. Again, model the problem using a number line as well as using the distance formula. All right, let's see what you got. So finding the distance between -7 and -4 is 3 units. And again, you could do it either way. -4 minus -7 or -7 minus -4. In either way, or in either case, you're going to end up with the absolute value of either 3 or -3, which is 3. Now we have a problem. Find the change in temperature if the temperature rises from -18 to +15 and use a vertical number line. So showing it this way shows us that we have a difference of 33 degrees, and it is positive in this case. So the difference between these two is positive. Then it asks, would our answer be different if the temperature dropped from 15 degrees to -18? And even though the change is 33 degrees because of what the question is asking, we would say that it changes by a -33 degrees. Now it's not just the distance, but we're also looking for, is it rising or dropping? So in this case, our answer would be -33 because that is what the question is asking. All right, then Beryl is the first person to finish a 5K race and is standing 15 feet beyond the finish line. And another runner is 14 feet before he finishes. So what is the distance between the two? And again, using a number line is very helpful to kind of visualize this. And they are 29 feet apart. And the change in elevation from 140 feet above sea level to 40 feet below. Again, 140 minus a -40 is 180. And so it shows that it's 180 feet between the two distances. All right, so to summarize this up, how can we use a number line to find the distance between two rational numbers? Well, we can count the number of units in between the two numbers. And what does it mean to find the absolute value of a number? We are finding the distance between that number and 0. So is it possible to use the absolute value to find a distance between a number p and another number q that is not 0? Well, yes. Instead of doing the absolute value of p minus 0, we would do the absolute value of p minus q, because we want the distance between the two numbers. And is distance always positive? Is change always positive? Well, if we're looking for distance, distance is always positive. But if we're looking for change, depending on the context of the problem, change can be positive or negative. So you always want to make sure you pay attention to the question being asked, if we're talking about distance or are we talking about change. All right, we'll see you in class.